Start with heat and AC test 7. Get our camera set up and everything. And we're going to start just reading these questions, plowing into them. Everybody got a pen? Got something to write with and all that? I don't have anybody that came without a pen today, did I? Which of the following best describes the low side of a system? This is an HVAC system. A, low pressure and low temperature. B, high pressure and high temperature. C, low pressure and high temperature. D, high pressure and low temperature. One of the things you need to remember about HVAC systems is temperature and pressure run together. And if, A is the right one. That's going to be the low side, is going to be the low pressure and low temperature side. That's the sweaty side, the big line that comes from the firewall and comes over to the...
You said something that didn't add up. You said A, but you said low pressure, low temperature.
And that's A. That's A. You got heat and AC test 7 there? Did everybody else have, yeah, that's the right one. What does A say? Read A to me.
A said low pressure.
Low pressure and low temperature. That's A, right? Okay, you got that? You look at it wrong, Willie?
Yeah.
Okay. Number 2. Which of the following best describes the high side of a system? That should be fairly simple too. High pressure and high temperature. Okay. In a properly operating system, the evaporator temperature is about what?
D.
That's actually going to be a D. It's going to be just above freezing. Now, what do we do to keep it from going below freezing? Anybody got any ruling to make on that? What do we do to keep our AC from going below freezing? If it goes below freezing, it turns into a block of ice and no air can go through it. So we don't want it to go below freezing, right?
Use the heater core?
No, we don't use heater core because the air that's going through the evaporator doesn't even see the heater core until after it's gone through the evaporator, even if your blend door is open. I mean, if your blend door is open. But what you're going to do there, you're either going to regulate the refrigerant flow with an expansion valve, and or sometimes you'll see a little switch that's got a little temperature tube that goes into the evaporator. In other words, it'll have a little alcohol tube that'll be going in, or a little electric thermistor that'll be going into the fins on the evaporator. And when the evaporator gets down to the temperature that thing's calibrated for, which is about 32 or 33, it'll kick the compressor out. Now the expansion valve is actually measuring the temperature of the suction side of that system, and if it gets too cold, the expansion valve is going to reduce the amount of refrigerant that's going through the evaporator so that it doesn't get as cold. And so there's a bunch of stuff going on there. Now on that Ranger out there, you're not actually measuring evaporator temperature. Ford decided on that one they're going to use temperature to determine what the pressure is. So you might notice if you're watching your gauges and that thing cycles off and on, it's going to cycle off and on when it hits about 24 pounds. All right, and so the pressure is what cycles it off and on and keeps it from freezing on the ones that have a low pressure cycling switch, and that low pressure cycling switch will usually be on the accumulator. There'll be a little, and Chevrolet did that for years on the fixed orifice systems, and so did Ford, and that kind of thing. Now, you know, Chrysler's a horse of a different color. They do things a slightly different way. They like to use expansion valves, but they have used orifices on, like on that Jeep. You remember that Jeep that you change the compressor on? They used an orifice too. So you don't always have an expansion valve on a Chrysler product. That Jeep was Chrysler as you can get. See. All right, so let's move on. The TXV. What is the TXV, guy? What's the TXV?
Thermal expansion valve?
Yes, thermal expansion valve is a good answer. It's located where? Where is the thermal expansion valve going to be located? Anybody know? Is it going to be at the condenser inlet, the condenser outlet, the evaporator outlet, the evaporator inlet? The thermal expansion valve. That's actually, I mean, that's a tricky question there, but it's still, I mean, the business part of it that's doing something is actually going to be mounted on the condenser, the evaporator inlet, not the condenser inlet. So it's actually going to be on the evaporator inlet so that it can restrict the amount of refrigerant coming and going. Now the other, you might notice these block style ones, like I had one laying up here the other day, I don't know where it is now. These block style ones actually have a big hole and a little hole. The big hole is where the temperature is measured that causes that variable orifice to change. If it's that expansion valve. All right, so basically you're going to put that on the evaporator inlet because it needs to control that. And on some of the older Volkswagens and European cars and whatnot, they sometimes have a screen in that thing, so that if that screen gets stopped up with crud, then your air conditioner just quit working. And you take that screen out and you can see it was clogged up. The refrigerant inside evaporator is what? Liquid, gas, liquid changing to a gas, gas changing to a liquid. Inside the evaporator. Where's the evaporator located?
Liquid changing to a gas?
Yes, yeah, it's going to be liquid changing to a gas, because what does it do when liquid changes to a gas? What's going on there?
Evaporation.
We're soaking up heat. We're taking in heat. That's what makes that evaporator so cold. And the fact that it's cold is a good thing. Now, has you guys ever seen that? Some of you haven't. I've got a swamp cooler over here. It uses water. It's got 4 cardboard panels that are specially made, and it's got a little pump, and that pump down there pumps water up there, and it trickles down those cardboard panels, and the fan pulls air through those cardboard panels, and it's got an oscillating nozzle on the top of it, and it's 15 degrees cooler coming out than it is going in. That's an evaporator air conditioner using water for a refrigerant. You got me? Well, anytime you're going to pull your air through something that's going to drop the temperature of it, you know, that's basically an evaporation thing going on. All right, let me see. The accumulator is very similar to what?
Receiver dryer?
Yeah, well, what do you think about that? It's very similar to a receiver dryer. The receiver dryer is mounted where? Where's the receiver dryer typically mounted, huh?
Oh, no.
It's on the receiver dryer.
You got a receiver dryer?
Line that comes down. But you don't have a.
What's the name of the line that it's mounted in?
Orifice.
Now, what's it mounted in, though? If it's got a receiver dryer, it ain't got no orifice tube.
Oh, it's a liquid?
Liquid line.
Liquid line.
It's a little thing, and it's no liquid line. It's like that little, when you see laying up there, it's a little bitty thing. And remember what I told you why it's little? Because there's a lot of PSI in there. The half side pressure on an AC system can go as high as 400 PSI. Now, there's a pop-off valve on the compressor, and if the fan quits running, think about it. If the condenser fan doesn't kick on, or for some reason or another, and you're sitting in traffic, the head pressure is just going higher and higher and higher and higher, and it's eventually going to cause the pop-off valve to go. And somebody will come in and they'll say, I heard a big noise under my hood, and then I saw what looked like smoke coming out from between the fender and the hood. And you know, if you notice that their fan ain't running, that's going to be what's caused that pop-off valve on the air conditioner. You know, it pops off at a certain, like 450 pounds or something, real high. Let's see. 2 technicians are discussing orifice tubes. Technician A says the OT is usually placed close to the evaporator inlet. Technician B says the OT is placed close to the condenser in some vehicles. Which one of those guys is right about that?
One not close?
Both of those guys are right. Now tell me tell me a fixed orifice tube a vehicle that's got a fixed orifice tube that's close to the condenser. What about an old Chevrolet pickup? Some of them old Chevrolet pickup trucks, you had to pull the grill off to get to the line that feeds the orifice tube is right there coming out of the condenser. And that liquid line is carrying low pressure liquid all the way to the evaporator, but it doesn't ever start to evaporate until it gets in there. Reach in there on my desk, there's 2 bottles of water in there, and I need one of them. If you don't mind there, Daniel. Thanks. Let's see. That was C, by the way. 7 was C. 2 technicians are discussing an AC problem. Technician A says an overcharge of refrigerant will cause higher than normal high side pressure. Is he right about that? What about Mitt? Is he right? Higher than normal refrigerant charge will that be high side pressure too high? Huh? Yes. Yes is a good answer. Okay, but we've only got half this question done. Technician B says a refrigerant overcharge will cause poor cooling. Is he right about that? Both those guys are right. If you put too much oil in there, if you put too much refrigerant in there, you're going to have cooling problems one way or another. You coat the inside of that evaporator with oil, it ain't going to work right. And you have to flush it to get that out of there, you know. And so that's what the flush machine is for. Okay. Most AC systems cycle the compressor clutch in regular intervals to control what? Why are they cycling the compressor clutch? What's the point in that?
So you don't burn up.
Condenser. Well, it says evaporator temperature, not condenser temperature. Evaporator temperature. In a non-cycling clutch system, evaporator freeze-up is prevented by controlling what? A non-cycling clutch system. See, not all of them cycle. You know what I mean? You might notice that even when you're looking at them. Huh? Evaporator pressure. Now, how are you going to do that? How are you going to control evaporator pressure? What about with the TXV? Huh?
What was the answer for number 10?
Number 10, basically going to be a C, isn't it?
Okay.
Yeah, evaporator pressure, C. All right. Flip the page. Imagine yourself taking an ASE test having to answer these questions off the top of your head. Two technicians are discussing variable displacement compressors. Technician A says they are designed to control evaporator temperature. Technician B says they're designed to control evaporator pressure. Which technician is correct? They're both correct. Now, do you know how a variable displacement compressor works? Have you guys seen this one that I've got out here that I spin with the drill? In the middle of it, it's got a slanted plate. And as you spin that plate, spins around and around, and the pistons go back and forth. Now, you took that apart and put it back together when you were in fundamentals. And you fought with it a while, didn't you? It was Booger Bear. But he got it, though. It didn't take you 2 days to do that. You did it in about 45 minutes, even though you whined about it. Okay, so what if you could take that plate? Now, think about this. This is really important. What if you could take that swatch plate, that angled plate that's actually, and change the angle of it so that it was straight?
It wouldn't work at all.
It wouldn't pump. That's right. So what you have is you've got basically a little piston that uses refrigerator pressure, and it's electrically actuated, and it can change the angle of that plate. Now, you're going to see compressors out there on really late model stuff that do not have a clutch. And this is how they change. They don't cycle the compressor, but they do have little breakaway things that can break in there. Like if you have a situation where it needs to let go, it'll actually break those little things and they can be replaced. But what I'm saying is that's basically a variable displacement compressor.
That 300, that one we put on there, it didn't have.
It had a.
It did. I never noticed.
It had a clutch. Yeah, I mean, it had a clutch.
It didn't cycle.
Yeah. Well, now it didn't cycle. Well, it didn't cycle, but you remember whenever it was giving trouble out there when the compressor locked up, it clicked in and it started burning that clutch and that belt and all that stuff. Matter of fact, when it clicked in and that compressor was locked up, it killed the engine, didn't it?
Yeah.
Remember that. If you guys think an engine's locked up because it's going don't, it won't turn, take the belt off and see if it'll start with the belt off. If it will, see which one of your pulleys is locked up. That's a simple thing. All right. So that was a C. An automotive AC compressor is the blank. An automotive AC compressor is of the blank type: scroll, rotary vane, reciprocating piston, or any of these. That's not a complicated question. Some of them have got reciprocating pistons. The one that Matt was just talking about with me. The scroll. How many of you saw that scroll compressor I took apart? You got one on there and a rotary vane. You got some of them. So they're going to be any of the above. Two technicians are discussing the lines used to connect the AC components. Technician A says they're usually rubber hoses with metal ends. Technician B says metal tubing is often used. Which one is correct? That's number 13. Both those guys are right about that. Now, Willie, how much rubber was there on that liquid line that you put on that Jeep? Weren't no rubber on it. It was all metal, wasn't it? Sometimes you're going to see a line that's all metal. Incidentally, I still haven't got any feedback. If you need a liquid line for that, like that 98 Pontiac that he's got, forget it. There ain't one. You just can't get it.
Well, you got to fabricate one or just replace
I don't think you can. I mean, you can't fabricate it even. Can't get it. It's not available anymore. That's kind of second rate. GM don't make it. The aftermarket suppliers don't make it. If you call anybody and say, I need a liquid line for a 98 Pontiac, if they've ever tried to look it up before, they laugh at you. Whoa. So you just ain't got nowhere. I'm sure somewhere somebody makes one, but I can't find them. I can't even get one from Ranshoe. All right, so let's see. A starved evaporator is one that has low pressure but a too warm temperature. This is due to what?
Restricted airflow? I don't know.
Everybody like that answer? What do you think? How about too low of a refrigerant charge? Starved means it ain't getting what it wants, right? And so what's the expansion valve, if it's got a TXV system, is going to starve it whenever it don't want it to be as cold. What if somebody told you that that their air conditioner, when they run the air conditioner in summertime, it wet the carpet on the right side of the car? Huh?
Heater core.
I mean, no. Yeah, but let's say that, how would you tell if it was heater core? Only when you're running the air conditioner in the summer. You got the carpet wet on the right side. You don't have no problem in the winter when you're running the heat. And so you got the carpet wet on the side in there. You got one of two things going on. You've got the drain that leads out of there plugged up with leaves and stuff, because leaves get down in there, you know, a lot of the time. The ones that's got a cabin air filter don't typically have a lot of trouble with that, but the ones that don't, leaves will work their way down there and they'll stop everything up. And that's a mess trying to get those things out of there, you know. So sometimes it's really aggravating. But they also, we had this one time George Baum brought his wife's vehicle in here. He said the whole right floorboard just gets soaking wet with water, and it's really bad in the summertime. And so what we would, we go there. What you do is you go in there and you find a place where the water is. You can tell if it's just clear water. If you want to use your refractometer or something like that, or if you want a taste of it or whatever, you can tell if it's got antifreeze in it. If it's got antifreeze in it, it's a heater core thing. If it ain't got no antifreeze, if it's just clear, cold water, then you basically have water getting in there. And on that Chrysler product, there was a TSB on that. And that hose is coming out through some foam, rather foam around where the hose comes out. And the hole is bigger than the tube, than the evaporator drain tube. And so when that water runs back, instead of dripping out, it'll run back down that tube, go in that foam, and just start a trail going, and all that water will go right back inside the car. And so the way you fix that is, sometimes you got to pull a little cover off to get that. You put a little silicone around that thing, so it can't do that. Then you'll have no more trouble. You got that? All right. You also got to watch about the evaporator drains dripping on the doggone oxygen sensor and various other components. You know, it makes a mess and causes them not to work. And you may have to actually put your little extension hose on it to route it somewhere else. All right, let me see. Desiccant is placed in the receiver dryer or accumulator dryer to do what?
I don't know this one.
Haven't you seen these little bags of things in a bottle of pills that says do not eat? That's a desiccant. That's right. It's supposed to absorb moisture. Let me see that. Let me see that cut apart unit right there. Let me see that one there. This right here is a cut apart accumulator. It's got a desiccant bag in it. You look, there's some little beads of stuff in there, and that little screen down at the bottom of that is what's supposed to keep these beads from getting in there to the, going into the compressor in case these bags bust. If that bag busts, they'll be just floating around in there. But anyway, that little screen right there there's a hole in the bottom of that tube, and it gets oil there. See, it can only pull vapor. That vapor is coming around here, and it picks up some oil, and then it comes out and it goes to the compressor, and that's how the compressor gets oil. But that desiccant is there to absorb moisture. And this thing's usually about that full of oil and refrigerant, whenever it's running and all that. There you go. All right, let me see. Refrigerant enters the evaporator as what? A low pressure atomized liquid, a high pressure gas, a low pressure vapor, a high pressure liquid. What do you think? Is everybody in here just waiting to have the answer spoon fed? The refrigerant enters the evaporator as what? Now, why would you do that if it needs to evaporate?
Low pressure vapor?
A low pressure atomized liquid because it needs to evaporate, right? How does it get atomized? It goes through the TXV or the orifice. It goes in there as a mist. I mean, it's just mists in there, and as it mists in there, it finishes evaporating and all that. And it doesn't really, it's just, that's the way that works. What I was talking about. Okay, let's rehash this for a second, because you guys have obviously gone south on me. Okay, it leaves the compressor as what? Comes into the compressor. A high pressure. Getting a compressor. It better not come out of the compressor as liquid. It's going to be a high pressure gas. Hot discharge line, right? The discharge line goes from the compressor to the condenser. High pressure gas turns into a liquid. Liquid line carries it into the evaporator. Right before it goes into the evaporator, though, it's going to turn into an atomized low pressure liquid, so it can evaporate in the evaporator and absorb heat. and then it's still absorbing heat coming all the way out of the evaporator to compressor. If one's fully charged like it's supposed to be, that thing is going to have, that suction line is going to be cold all the way to the compressor. It should be. If the accumulator is cold, you know, on these orifice system, that's okay, but that line needs to be cold. And sometimes they get so cold they get frost on them. You ever see them do that? And all that? No. But anyway, if it's working like it's supposed to, let's say that you're working on a piece of heavy equipment. And let's say that you put a compressor on it because the compressor went bad and something happened, it lost its refrigerant charge, you got an empty system. You put a new compressor on this thing, and you don't know what the charge is. You don't know how much to put in this darn thing because it's been manufactured by somebody that didn't publish specs. So you need to know when to stop putting refrigerant in it, don't you? So how are you going to determine when you've got enough refrigerant in there? I'm not going to feel register temperature. I mean, later I am, but to start with, when I'm out there under that thing, I'm going to have my hand on that suction line right down there by the compressor with that thing running, and when that suction line, I'm letting my refrigerant go pull in, I'm letting it go in through the low side when you're doing it this way. Compressor's running, the pressure is low, the pressure in the tank's high, you're naturally going to have transfer of refrigerant. I'm going to keep feeling that darn thing, and you know, I may turn off my refrigerant, let it run a little bit, and when it's cold all the way to that compressor, I'm done. You got me? That's how you're going to tell. When it's cold all the way to the compressor, you're done putting refrigerant in it. If you're just doing it like on a tractor or something like that. Now, I'm going to reiterate this. It's never okay to go out there when you're working on one and let the refrigerant hiss out into the atmosphere. That's illegal, and you will get locked up by the NSA because they can actually detect that with their, you know, spy program, and they'll put you away for that. Don't try that, okay? Make sure you've got the right equipment to recover the refrigerant and put it where it's supposed to be. It's a good idea. There's actually some equipment that you can haul around on your truck to do that. But one way or another, that's how you're going to do it. Now then, receiver dryer accumulator is placed in a system where? Where is the receiver dryer? Wait a minute, not where. It's got a different kind of answers. A, as a storage tank for the refrigerant. B, to prevent the system from being overcharged. C, as a separation between the high side and the low side. Or D, to meter the refrigerant to the evaporator.
D.
And number 17 is A, as a storage tank for the refrigerant. It's not going to meter the refrigerant. It's not going to act as a separation between the high side and low side. It ain't going to prevent it from being overcharged. That's the only way. It's got a little storage tank for the refrigerant there. And there's some oil in there too. Which system utilizes a receiver dryer? Cycling clutch orifice tube system, variable displacement orifice tube system, variable displacement thermostatic expansion valve system, or none of the above. The C is the right one for that. I've hammered on that until I was blue in the face. And y'all have never seen me blue in the face, have you? All right. Yeah, let me see here. Let's see. Number 19. Refrigerant entering the condenser should be what? Refrigerant entering the condenser should be what? High pressure liquid, low pressure vapor, low pressure liquid, or high pressure vapor?
Low pressure vapor.
High pressure vapor. That's the discharge line. Remember that? When I say evaporator, condenser, whatever, you guys ought to be able to instantly think about where that is and what it's doing. All right?
I think about where it is.
Yeah, you got to think about not only what it is, but where it's doing. I'm trying to build these neural pathways in your guys' head and let those neural pathways, it'll recruit some more neurons, and that little highway will get wider, and it'll be a second nature thing, right? I mean, like there's some stuff. I mean, I'm not trying to toot my own horn, but there's some stuff I've known so long, I think everybody knows it. And then I'm shocked when somebody puts the lug nuts on backwards. What in the world is this about? You know, they turn it around where the cone's pointing out. I got one of our state cars in here when they're going to rotate the tires and found the lug nuts put on there like that. I couldn't figure out who did that. I mean, you know, of course you get this, not me, not me, not me, okay. What is the state of the refrigerant and the accumulator? Both A and B, vapor and liquid. It's got vapor and liquid. We're not talking about temperature, all right? Modern automotive refrigerant systems can be all of the following except what? It can be any of them. It can be orifice tube, variable displacement, thermostatic expansion valve. Now then, okay, we got a little picture here. We got a picture. What type of refrigerant system is shown in this illustration? In this illustration, what type of refrigerant system is shown? Okay, what is the heat exchanger at the bottom? Okay, what's the one at the top? Okay, does this have an accumulator or receiver dryer? Does it have an expansion valve or an orifice tube? An orifice tube. So what kind is it, gal? Give me an answer, okay? I said it has an orifice tube, right? Alright. That's basically an A there. Some hybrid vehicles uses what kind of a compressor to keep the AC system operating in cases where the engine is off?
C.
They're going to use either B or C. That's either a belt-driven / electric hybrid. Some of them have got a, I mean, or both. You know, they'll actually have an electric part that drives them whenever they're needed. Okay. All right. Now then. Okay, where are we at? Flip it over. Choose the item in column 2 that best matches each item in column 1. Use this drawing to identify the components. All right. Somebody talk to me there.
Hey.
Okay. What is that one?
J.
Okay, that's 24 is J. What's 25?
Wait a minute.
Oh, backside.
Backside.
Let's say component A.
No, what's 24? I mean, what's it? Number 24 is what?
J.
Here's a evaporator.
Yeah, the J. In other words, excuse me. All right, what is component, what's component K? Can you tell me? All right, now look at this. 26 is what? Is A, right? 26 is A.
That's what, okay.
Got that?
Wait a minute.
Your answers are going to be down here by your numbers.
Okay, it's a component A, right? I'm just going back to 24.
Yeah.
Component A.
Yeah.
That's number 24. That's the evaporator, right?
Well, actually, it's going to be it's going to be J. Yeah. There you go. See, condenser is basically what that's going to be.
Okay,
so you're
so
basically supposed to go to the other side, other column. J's component A matches up with J. Just draw a line or whatever, or write it on the right on that blanks on the right side. You got that? You need to be able to see that. I was holding it up that way. All right, you're going to look at that. Keep going. Somebody tell me what number 26 is.
26 component C is A.
That's A, right. What about 27? 27 is I.
That's service point.
All right, what is I?
Wait, that's low service point. I is.
I is a low service port.
I thought that was high.
Why would it be high?
I thought K was. Alright, never mind.
You see it anywhere? All right, the I is over there. Look down there, third from the bottom in that middle column there, Webb. Third, that's the low side service port. Which basically, this is kind of dumb the way they got this put together. I mean, that guy, low side service port matches up with K, doesn't it? Component K is a low side service port. You got me? All right. All right, which one have you not answered? What about G? 28 is G. Got that? Which is what? What is G? 28 is the evaporator, isn't it? I mean, yeah, the evaporator. 29 is E. 30 is Charlie. 31 is Baker. 32 is Frank, or Foxtrot if you're left-handed. 33 is Delta, and 34 is Henry. I don't like the way that matching thing was set up, and so I just blew through it and gave you the answer. That was really lousy, the way they did that. It was confusing, and I don't think you would ever see, you're never going to see anything like that on an ASE test. What's that?
Let's run through that one more time.
25 is K. 28 is George.
27 was I, right? India.
27.
Indigo. 27 is Indigo. That's the, what's that, low side port? Is that what you said? Okay, the service port. Look, what they really should have done, and that's kind of silly, what they should have done was what I, heat and AC test 8. Let's jump into this one and let's get through with it. We got about 25 minutes till it's time to have something to eat. In a reciprocating piston compressor, the pistons are driven by what? They can be driven by any of those, a wobble plate, a crankshaft, a swash plate. Have you guys ever seen those little square looking compressors like they used to put on Ford pickups and stuff? It's a square compressor that had a little head with bolts on it and all. You take that apart, it looks like a miniature engine. It's got a little crankshaft with a piston in it, little sputter valves in there. I've got some over there somewhere. Most York compressors use cylinders made from what? They're going to use aluminium. Put an extra I in it like the Brits do. Aluminum. The reciprocating piston compressor used on many older General Motors vehicles is designated by which of the following? Oh, this is a rich question. That's an A6. An A6 compressor. Two technicians are discussing variable displacement piston compressors. Technician A says the wobble plate is moved to the high angle position for maximum output when the cooling load is high. Now what are we talking about when we talk about a cooling load? What's a cooling load and what's a heat load? You remember? What's a heat load and what's a cooling load? If something is hot and it needs to be cooled, that's a cooling load. If something is cold and it needs to be heated, that's a heat load. Basically, the burden is on something to move it from where it's not to where you want it to be. That's the load. Imagine yourself having to carry a bundle of shingles up onto the roof of the house. That's a load, isn't it? It's down here and you want it to be up there, so you got to put it on your shoulder, that's 96 pounds or whatever, and walk up the ladder with it. You ever carry a bundle of shingles on your shoulder?
Carried a lot of paint, like or 50 or 5 gallons.
That was rough.
Full seal.
Carried them right up, didn't you? All right.
Never carried shingles.
Okay. Technician B says the wobble plate angle is controlled by the pressure in the crankcase. Who's right about that? Well, it's C, basically, the way that they got that thing set up. You probably need to be studying on that. The General Motors variable displacement compressor has how many cylinders?
4 or 5.
Anybody got a better answer than that? How about 5 or 7?
I knew there was 5 at least.
All right. Which of the following is an advantage offered by a scroll type compressor? What do you think? A, low engagement torque. B, smooth engagement. C, ability to use a small clutch. Or D, all of these. That's all of these. See, that's basically for space saving. It's not very long, it's not very fat, and the clutch is little. Now why do you put, now let me ask you this. Why do we put, let's figure out some of the components under your hood. I'm going to pause for a second to just do a little mechanical engineering here. You're building something, and the what components under the hood have got, you know, we're talking about the crankshaft is the one that's going to make all of them move. So which components under the hood have got the biggest pulleys? No, we're leaving the crankshaft pulley out of it. The components that are driven by the camshaft. Well, let's start the other way. Which ones have the smallest pulleys? Why does the alternator have a small pulley?
It spins faster.
It needs to spin really fast even when you're idling, so you're going to put a little pulley on there, right? You know, some of them have 2 alternators on them, like some of them diesels and all. They'll have pulleys 2 different sizes on them, but you won't be able to look at them and usually tell, but they're slightly different sizes. All right, now, what has the biggest pulley you can think of that's being driven by the crankshaft? That's close, but what about the power steering pump? The power steering pump has got a great big old pulley. Now, why do you put a great big pulley on the power steering pump and a little bitty pulley on the alternator? What does yeah, I mean, so what is the power steering pump doing? It's a hydraulic pump. It's got to put up 1,200–1,500 pounds of pressure. You better put a big pulley on that sucker if you want it to. It ain't going to spin very fast, but it's going to be powerful, right? Think about it. Now, you ever think about that before? The reason they put the size pulley on them they do is because of the load that's on that particular component. Now, the air conditioner has got a pulley that's only slightly smaller than the power steering pump, and that'll give you an idea of how much trouble that thing is to spin. Now you can use a smaller pulley and a smaller clutch on a scroll type compressor because it doesn't take a whole lot of power to pull it. The downside about a scroll type compressor is they just sort of go bad, and you have to put some on there, and they're kind of expensive to build too, from what I've been able to tell. You know, they seem. All right, let me see here. Let me see. Number 7. Blank. A blank is used to seal the opening for the compressor drive shaft. That's going to be A, a carbon seal cartridge, B, a lip seal, C, both A and B, or D, neither A nor B. That's going to be a C. The little carbon seal cartridge is a very interesting critter if you ever have to change one. We used to have to put those all the time. Most of the time, though, I'm going to tell you that a lot of your shops now, most of them, if it has a leak in compressor, we just put a compressor on it. And as a matter of fact, I think the compressor for that Crown Vicky will be in this afternoon, Harrison, so you can just finish that job. Hopefully the UPS guy will have it when he comes. You know, with all due respect to UPS, if they tell me it's coming on UPS, I know it's going to be a while before I see it. Especially if the guy at the parts house tells me that. A lot of slips between the cup and the lip. Hey, why didn't it come? Well, they didn't get put on the truck. We didn't get it down there quick enough. You know, there's all kinds of stuff I have to think about. All right, 2 technicians are discussing refrigerant oils. Technician A says the mineral oil used in R12 systems is completely compatible with R134A. That's a bunch of hooey. That is dead wrong. Technician B says a synthetic oil should be used with R134A. That's number 8. That's B. The B is the one I got to pack up. 2 technicians are discussing thermal expansion valves. Technician A says the TXV senses evaporator temperature to control the valve opening. That's what I was saying earlier. Technician B says the TXV senses the evaporator pressure to control the valve opening. Is it temperature or is it pressure?
Temperature?
It's actually both, because pressure and temperature run hand in hand. You know? Now, a lot of the times these evaporators will have a little sensing bulb on a long alcohol tube that'll have some of that rubbery tape, that pressed tape, you know, taping it to the evaporator tube. And in that case, it infers pressure by checking the temperature. All right. 2 technicians are discussing AC systems. Technician A says thermal expansion valve systems use a receiver dryer mounted in the suction line. Technician B says orifice tube systems use an accumulator in the suction line. Which technician is correct? Wait a minute. Is the receiver dryer mounted in the suction line?
Yeah, it's on the liquid line.
There you go. That's the answer I was looking for. Okay. Give that man a gold star, you know, whack him on the knuckle. All right. All right. Yeah, well, the fitting found on an accumulator is for what? What's it for? Is it for leak detection, low side service, high side service, or for flushing? What do you think? It's actually B. It's for low side service. There's also a fitting on there that'll look like an R134 fitting. I mean R12 fitting. That's where you screw your low pressure cycling switch on there. Okay. One time there was this guy that came over there to me and said, my air conditioner's not working on my Chevrolet pickup truck. And so I went out there, and I know a lot of them Chevy pickups of that vintage, which was 70s stuff, and his truck wasn't that old at the time because this was in the 70s, had pressure cycling switches that let it go bad. And so I unplugged the pressure cycling switch, got a little piece of wire and jumped it around, and the compressor kicked on, and the suction line started getting cold and all that, and he started getting the good air. And I said, you need that pressure cycling switch. And he says, well, that's cool. How much to owe you? I said, $65. He said, $65? All you did was jump a wire. And I said, yeah, but I knew which wire to jump. But I didn't charge him anything. I just told him to get it and all that. But, yeah. And people ask what they owe, you know, they're handing you a silver platter there. Okay. Oh, let's see. Filter can be installed in the liquid line for which of the following? A, when the system is contaminated. B, instead of flushing the evaporator. C, when extra moisture removal is needed. Or D, all of these. That's number 12. That's only A. Now, what they used to do, and I want to tell you this, let me bounce this off of you right quick, it's pretty important. They used to have some of these that had, whenever there was a contaminated system, they would take the liquid line, and there was a filter that you would put in there, and you'd put that filter in there and you'd charge it up. I mean, and the filter basically was an aluminum thing with fittings on it, and if you just looked at it, it kind of looked like that. And it had fittings that you'd have to, you know, get into that line and compression fitting stuff, and you would fire that system up and you'd run it for 30 minutes with that filter in that liquid line. Just run it for 30 minutes. Now, where's the liquid coming from? In the liquid line, the liquid, which way is it flowing and where's it coming from? Which component is coming is putting out the condenser? Coming toward the evaporator from the condenser, right? Because condenser's what.
All right. See, I don't know why I got it. I'm always coming from the firewall this way when I should be going the other way.
Well, actually, it's coming from the evaporator to the compressor through the discharge line from the condenser back to the evaporator. So you're in the liquid line with this thing. All right, that thing that you put in there, you're going to leave it in there for 30 minutes, and then you're going to take it off, you're going to throw it away, and they got another one that you put in there, and you leave it in there. So you're stopping all the, you know, the screen in there is going to stop all the crap from, you know, going anywhere. It's going to capture it.
So like you put in the compressor.
Yeah, it's actually in the line. It's going to be in the liquid line.
Mm-hmm.
You know, basically is the way you put that in. In other words, so it's going from the condenser through here to the evaporator, but you're stopping it right there. You're stopping that trash.
That's the part where you.
No, the piece that you and I put in there, we put in the suction line.
That line right there, that's that part. So you take it loose and you put a little.
That would be like the line you replaced on Ed's Jeep.
On that Jeep. Man.
Yeah, you would actually cut that line and put a compression fitting in there. You know, they got little, so you put it together like that. That's the only way you can stick that in there. You see what I'm saying? But that was something we used to do when Ford prescribed on theirs, you know, if you had a contaminated system. It's really important to contain those filings or they'll ruin. I put an air conditioner compressor one time on a Chrysler product, and I knew how to pull the air out, and I knew how to charge it up with a refrigerator, but I didn't know much of anything else. And so I took bought a compressor from Parts House. You know, V8 Chrysler used to have these V-shaped compressors up in the front. I put one of them on there, sucked it down, charged it up, fired it up, and it ran about a half a day, and it started knocking and giving trouble. And so I called the guy at the Parts House. He said, well, where'd all that metal come from that came out of the original compressor? Oh, I didn't think about that. It actually just went through there and wiped out the compressor. So what I did on that, I didn't have no flush machine. I got denatured alcohol and just poured the evaporator full of denatured alcohol and put a line coming off the other side and got my shop air and blew that denatured alcohol on through there. Did that 2 or 3 times. I got all kind of metal particles out of the evaporator. Did the same thing with the condenser, same thing with the lines, put it all back together, and that thing's still running as far as I know. You know, I sucked it down, put oil in it, put it back together like it's supposed to. And heck, that was a long time ago. You know, you can practicality, you know. I might have got my hand slapped by some of the manufacturers for doing that, but it worked. All right, let me see. Where are we at?
13.
13. Set pressure cycling switch does what? What does it sense? Low side pressure? Does it sense condenser temperature? Does it close the thermal expansion valve? Or does it sense high side pressure? You guys better remember this because I'm liable to ask you any of these questions any time of the day or night. Huh? Senses low side pressure. It's going to cycle the compressor based on low side pressure. 2 technicians are discussing line fittings. Technician A says many early AC systems used flare fittings. Technician B says modern systems commonly use O-rings to seal the fittings, and these are much easier to repair than flare fittings. Which technician is correct? See, I want to tell you something. The flare fitting, sometimes, like if you're having to change the orifice tube on one of these Chevrolet trucks, be prepared to go ahead and sell them a condenser, because them things, whenever you try to break them loose, most of the time they will not come loose. They're just all seized up, galled together. You can't get them apart like they're welded. All right, but I like the ones that, you know, the spring lock coupler lines, they can't do that, see. The hose that connects the compressor to the evaporator is commonly called the what? I told you this earlier. What? The compressor to the evaporator is the suction line, guys. That's the big fat one. Got it? All right, you guys are supposed to know this. Burn it in. List, define, explain. Webb, a fixed orifice tube. A has pressure sensing capability. B has temperature sensing capability. C has an internal valve. Or D is usually located in the evaporator inlet or line of the evaporator. Well, you know. That's only D. He's right. Which type of refrigerant hose is used with an R134A system? Number 17, that is A. It's a barrier hose. R134A is a smaller molecule than R12. And if you had a little bit of a leak with R12 and you convert it to 134A, you're going to have a big leak. Because the molecule is smaller, more of it will come out. All right. Whereas an air conditioning system may use an inline filter to do what? What do you think? Number 18. Remove moisture, separate large debris from small debris, reduce compressor noise, or prevent any solids from clogging the expansion valve. That's a D. That's right. I've seen them. You know, that's what I was talking about earlier. And when that clogs that screen, you ain't got no air. An air conditioning system may use a muffler to do what?
Reduce noise.
Well, now what's wrong with that answer? Reduce noise. What does a muffler do, you know? What's the function of the desiccant bag inside an accumulator? Sure enough. Now you guys know that when you replace a compressor, you're supposed to replace the receiver dryer and the evaporator. I mean, the accumulator, excuse me. Because if you don't replace that receiver dryer or that accumulator, they don't like to warranty the compressor. A variable displacement compressor uses what? Number 21, that's B actually, a variable angle wobble plate. I like to call that a swash plate, but they call it a wobble plate. Which of the following is not a major component of most compressors? A, clutch. B, fins and tubes. C, piston and rings. D, reed valves. This is going to be a B. We don't know fins and tubes on there. Identify the component shown in this picture. Ding, 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 ding. It's on your test. What is it? What is that component?
High voltage compressor package.
Do you notice where it says bright orange high voltage wire?
High
Okay,
voltage.
23, that's going to be B, isn't it? That's going to be B. Identify the component illustrated below. What is that component there? Everybody like that answer?
Yeah.
It's going to be B. That's an accumulator. All right. Okay. Identify this component.
Receiver dryer.
That's a good man. Receiver dryer. Number 26. A damper drive compressor turns the compressor input shaft A, only during high moisture conditions. B, whenever the clutch magnet is energized. C, whenever the engine is running. Or D, when the engine is in auto stop. That's actually C, whenever the engine is running. Write T if the statement is true and F if the statement is false. The compressors on some vehicles use a clutchless design and a variable displacement. That's true. I talked about that earlier. Some systems have a modulator instead of a receiver dryer. That's 28. That's also true. A compressor clutch that cycles on and off rapidly is an indication of what? You guys have seen that before. Low refrigerant charge. Why did you guys have fun with that test?
Why would you do that if they have low refrigerant?
Because of the suction, I mean that low pressure switch is going to, whenever the low pressure goes low, it opens the compressor up. You can watch it. If you watch that gauge, it'll go down to like 24 psi, and it'll come back up and go down, come back up. Short cycling is what they call that.